Again, welcome back to calculus. In these lectures, we're going to learn how to find the derivative of exponential function. Now, a derivative of exponential function, always the answer is the same. So f at x equal to e to the power x. The derivative of f at x also is equal to e to the power x. Therefore, we can say y equal to e to the power x as a derivative equal to itself. And it's the only function that has this property. So again, y equal to e to the power x, the derivative of it also will be e to the power x. So our first example, we have f at s equal to 3 times e to the power x. So we can take the constant value first out, then we find the derivative of e to the power x, which will give us e to the power x. So our answer will be the same. 3 times e to the power x. Now, the second example, we have f at x equal to s squared plus e to the power x. So we can find the derivative of s squared, which will give us 2x. Then the derivative of ex will give us ex. So our answer will be 2x plus e to the power x. The next example, we have f at x equal to sin x minus e to the power x. So we look for the derivative of sin x will give us cos x. Again, the derivative of ex will give us ex. So our answer will be cos x minus e to the power x. Next, we have a f at x equal to negative 2 divided by 3 times 4th root s cubed. So we can rewrite negative 2 divided by 3, then we find the derivative of x to the power negative 3/4. Why negative? Because we move the x cube 4th root to the top, to numerator. So we change the exponent to negative. So here we can use the power rule, and we're going to get negative 2/3, then negative 3/4, x minus 3/4 minus 1. Minus 3/4 minus 1 will give us minus 7/4. So we can cancel the constant values here. Negative times negative will give us positive. 3 will cancel the 3. And 2 divided by 4 will give us 2 at the denominator, the bottom. So we get 1 over 2 times 4th root x 7. Now, since 7 is greater than 4, we can take s4 out, because 4th root x to the power 4 will give us x. So we are going to reduce the 7 to 3, and we bring x out. So our final answer here will be 1 over 2 x to the x times 4th root s cubed. Next, they say we should find the derivative of the following function. Now, here we have to use the chain rule. We said that y equal to e to the power x, the derivative of it is the same e to the power x. Now, if we have e to the power 3s plus 2, we have to find the derivative of 3s plus 2 first. That's using the chain rule. So here we say the y derivative will give us g derivative at x times f at x. So the derivative of 3s plus 2 will give me 3. Then derivative of e to the power 3s plus 2 will give me the same value, e to the power 3s plus 2. So our final answer will be 3 times e to the power 3s plus 2. The next example, we have y equal to e to the power s squared. Again, this is supposed to be s squared. S squared plus 4s minus 1. So we use the chain rule. We are going to find the derivative of s squared plus 4s minus 1, which will give us 2x plus 4. Then we write the f at x, which will be multiplied by e to the power s squared plus 4s minus 1. So the final answer, we can take 2 out of the parentheses here, 2s plus 4. The common value will be 2 times s plus 2 times e to the power s squared plus 4x minus 1. So in these two examples, we are using chain rule, and we're going to cover chain rule in the future lectures. So that will be the conclusion of this lecture. So our main objective here is to go through the concept on how to find, again, derivative of exponential function. Again, thank you for your time.